Okay, so welcome to day 3 of the CG School with Factory 15. We're going to be talking a lot today about rendering animations, and the large portion of today is going to be talking about compositing within Nuke. So the first thing we're going to kind of briefly talk about is just rendering animations in Max, and lots of people already know how to do this, but there might be a few tips and tricks that we're missing or forgetting about, and it's amazing how many people still suffer with flicker and noise problems within animations. So we're going to just be running through how to render kind of simple fly-through animation and showing some examples of when this is appropriate to use. Rendering moving objects in a simple way. When you've got a couple of moving objects within the scene, it can be really annoying when you kind of feel like you should be able to pre-calculate in a fly-through method, and you end up having to pre-pass or render in brute force to kind of resolve flicker issues on objects within the scene that are moving. And we can there's simple ways where we can resolve this and pre-calc in a simpler way. And then we'll be looking at rendering full-on moving object scenes, which are kind of dynamic and a lot of things are moving, which we need to pre-calc fully. And then we'll be looking at the transformation scene in Jonah again, but looking at how specifically we kind of set up that scene with our lighting and our render settings. And then we'll be looking at the elements that are needed for compositing within Nuke and how we will rebuild our RGB within Nuke at a basic level, getting everyone used to the interface. And the passes we'll use to kind of adjust our scene. So rebuilding RGB in a simple scene. And then we'll be looking at Nuke Advanced, and we'll be looking at a few of the key features on building complex trees and organizing your files so that you're on top of everything, and the benefits of being able to see everything within your comp. We'll also be touching upon how we've kind of started using Nuke for our image workflow within ArcViz, and how it's kind of changing the way we kind of develop a kind of image set within Architectural Visualization, and how we can kind of speed up the initial changes and process that we all kind of have issues with when we're dealing with architects and developers, and how we can kind of generate changes and get feedback back to the architects very quickly, and then we wait for the kind of final time-consuming Photoshop work only for the final pass of the process. So, first of all, let's just talk a little bit about rendering static scenes within Max and how we can kind of pre-calc our scenes. So let's look at some examples of where this is kind of appropriate. We'll look at the kind of rendered scene here. What we've done is we've created a scene here with different setups. So this is the kind of static setup where nothing's moving. We have another one where just our spheres here are moving, and then we have another one where everything's moving, and we can kind of tackle each one separately. So let's look at some static scenes. So this is really appropriate for kind of chalk fly-throughs or anything where a scene is just not moving at all. This is a very simple animation that we created for in a few days, where we kind of had a static scene, nothing was moving, and we were simply flying through the space in a kind of nice chalk way, and then some of the static images were kind of popping up to explain the space and connect the images together. It was really just an image set which they wanted to kind of try and communicate where these images were sitting within the building. So locating each of the images, and the kind of fly-through was a vessel to do that. So these are really simple scenes to set up, chalk fly-through, and often we don't actually render every frame for these things. We render every other frame, and we use frame blending to kind of cheat. So when we're in kind of tight deadlines, we can only render half of what we need. But setting up these kind of scenes are very easy. And we'll try and show that again. And then again, even on the creative side of things, with a film like Megalomania, if we kind of skip through to some of this, a lot of this was apart from certain elements, a lot of this was kind of just rendered in fly-through, and with very simple scene setups, and render times were very low. Some elements were moving objects later on in the film, but most of the film was very static, moving through simple scenes with nothing moving. So in both accounts, we need to set up our scene. So basically, what we need to do here is we want to generate our light cache and a radiance map. Now, there are different ways that people are showing you how to do this on the internet, both of which, all of which are slightly different, whereas the method we use is to bake it in one pass. Certain techniques use a kind of light cache technique first, and you do it separately. However, there's no real need to do that. You don't really need to kind of set up your light cache, and render it on fly through as a separate pass. You can do it all in one. So traditionally, you would set up your system like this. You'd have light cache set. You would have fly through set in the mode, and that's the same as setting use camera path. So you don't need to have both settings selected in this way. And then ideally, you want your scale of your light cache to be on world. And when you do this, you really need to up the subdivision size of your samples here to something more like 2,500. And what this is essentially is world setting will calculate the kind of 3D scene, and the whole scene is one light cache file, where a screen will just do what you see within the screen. Now, this isn't advisable to use when you've got a huge scene, where there's lots of different objects and a large scene around your camera. But in this scene, for example, it's what we see in our camera is more or less what we see in what we have in our model. So if this was a small part of a much, much larger model, then we wouldn't really want to use world, because we're not going to get enough subdivision around our space to kind of generate a good light cache. So, but on this scene, it's appropriate to use world. All interior scenes, you should be using world. However, on exterior scenes, large exterior scenes, screen can be fine. So on screen, light cache of 1,000 is normally good enough for animations. And on world, a light cache of 2,500 is normally quite appropriate. Again, you want to check the number of the cores in your machines or your render farm, and just make sure that you're generating the passes, the number of passes within your light cache reflects that, because otherwise you've got power in your computer that you're not using. If you use the default 8, then you've actually got 12 cores within your machine. So what we want to do if we're in this traditional model of saving out the light cache is that you want to set this to fly through. You want to go to Save File. You want to go to, you want to save this file as something sensible. Normally I call it whatever the file's called, underscore light cache, or LC. We'll call this LC CG school, because we've already generated ours before. And then what you want to do is, because you've set this to fly-through mode, you don't need to render the entire frame range here. You want to render a single frame, because the fly-through mode will automatically create a map which is generated for the entire length of your timeline. So if we set this to every frame, what it's going to do is it's going to kind of generate that same light cache file 100 times, and we don't want that. So once we've set that up, we also want to remember that we don't want to save the image in the Vray frame buffer or in the common settings. And in the global switches, we want to turn on don't render final image. So we don't actually want to render the final image, we just want to generate the light cache. If you accidentally leave this on, it's not the end of the world. You'll just have a funny image sequence or image that will look like a light cache pass or an Irradiance map pass. And when you come to rendering anyway, it will kind of overwrite those files. But it's good practice just to turn this off and turn your elements off. And there's nothing really you have to change within your settings. Whatever your final render settings are within here should remain within your in your pre-pass. So this will generate one light cache file, which will look very strange, and it will represent your entire animation that you've got in your timeline. It will kind of be like a soupy zoomed version of this. But you can do this while generating the Irradiance map. You don't have to do this as a separate pass and then load the Irradiance map and load the light cache from file. You can leave this setup as you've set up, as you've made here, but you can turn your primary G-engine to Irradiance Map, and we can set this up to generate our pre-pass at the same time. Now, this is slightly contradictory because we want to generate our light cache on single frame, but we want to generate our Irradiance Map for however many frames we feel like we need to create enough detail. So when we're generating this in this method, the pre-pass, what we want to do is put it on a range and then our nth frame on whatever we feel like we need. Now, this is very dependent on how complex your scene is, how complex your camera move, but the point is we don't need to generate a Radiance Map or a pass for every single frame of our animation, because the difference between the data in all of these frames are very minimal. So we could probably experiment and actually only do 3, because we think we've got information there, and information there that might need calculating, and then we can use all of that information later on. So we can probably get away with only 3 light cache pre-pass files here to actually create all the information we need. I don't normally risk it with that little amount of Radiance Maps generated. It's always good to have a little bit more data. So in this case, you could probably put it on every 20 frames. So it's going to create a map here, a map here, a map here, a map here, and so on. And again, it's just a kind of experience thing with what you should set this number to with how much your scene is actually moving. So again, how are we going to get around this issue that the light cache only needs to be generated once, yet we're wanting to generate an image every 20 frames or a pass every 20 frames? Now what it does automatically when you generate your light cache on fly-through mode, when you have your Radiance Map set to multi-frame incremental, is that it will generate that light cache file on the first frame, and then it will render the Irradiance Map for that first frame. And then when it goes to the next frame, which you've set to frame 20, for example, it will automatically bypass the light cache and jump to the next iteration of the multi-frame incremental. So it does it automatically for us. So we don't need to go through that first stage and secondary stage of generating our light cache and Radiance Map separately. We can do it all in one pass. And that's great because sometimes, especially if you're setting up loads of files and you'll have to rendering through Backburner, then it's really annoying to have to keep sending light cache, Irradiance Map, light cache, and then the render files. You're sending 3 files per scene setup that you're sending. And if you're sending a lot, it can get confusing. If you're sending things to Backburner and you're having dependencies of these things, then it can be really annoying, because once you've sent your thing to Backburner, you have to essentially, this isn't going to be able to connect, but I can illustrate this here. You'll have to load your different light cache Radiance Map files as dependencies of each other when you send your render, and there's a lot of room for human error in that process. So if we can get rid of one of those steps, then it's going to be much better for us. So we want to also save out. We've set up our light cache, which we could have done when we had it on light cache Radiance Map or light cache. It doesn't really make a difference. And then we want to set our Radiance Map to multi-frame incremental, and we also want to save this as well. So I've generated mine before, but we'll go to CG School again, create a new version, or save a new version. And what this is doing, it's creating, in both cases, it's creating a dummy file. It's creating a file that you can read to be able to then go to the next step. So you don't have to generate the map before you actually can send both sets of pre-passes and the actual final render file. So it creates this kind of dummy blank file that you can set and load from file to actually then send the render. So we put this to multi-frame incremental. We have to definitely check auto save and browse for that same file and press save. It'll ask you if you want to replace. You say yes. And you have to do that for the light cache file as well, just in case that it's not loading the previous file. So light cache CG School, replace, yes. And now you've linked this properly so you can generate this pre-pass. We've got our don't render final image selected. We have range from 0 to 100 every 20 frames. And we're going to render through Backburner all on our local machine. Now, it depends on your complexity of your scene. Sometimes for simple things, you can do that locally. Just generate this all locally, and then you're kind of ready to send your final render to your system. What multi-frame incremental is going to do, it's going to kind of save over the map every time. So at frame 0, it's going to generate the map. At frame 20, it's going to add a detail to that map. Frame 40, so on and so forth. So we can't send this to multiple nodes, to multiple machines. This has to be generated on one machine. And normally the workstations in your office will be more powerful than your render farm, and certainly in terms of RAM and things. And this section is very much dependent on RAM. So I tend to generate this locally because I've got a powerful computer that I use, which is much better for generating the light cache and Radiance Map, the pre-passing things, and then the final render gets sent to the farm. So this is going to work on one machine. Once we have generated our map, we can then put this on from file, and we can browse and make sure that it's linked to the right file, CG School. And even though we haven't generated this map in our tutorial here, it's still giving us the option to select it. So we don't have to wait until this is finished on whatever computer we've sent it to load it from file, and our multi-frame incremental from file, CG School. And now we want to turn back on or turn off, don't render final image, turn our passes back on or whatever elements we've got active, and then remember to turn every nth frame back to 1. It's a really easy mistake to leave that, and then you end up with 5 frames. So now we're ready to send this. We can send it to our farm, and we can select, once we've sent this we can select dependencies. If we've sent our multi-frame incremental job to the farmer and it's still rendering, we can select it there. And that's going to make sure that the rendering doesn't attempt to start before our pre-pass is complete. But we don't need to do that if we've generated it locally and it's all on from file. We can just send the render, and we're ready to do that. And what this is going to do, it's going to give you a very simple animation, which is flicker free. So this kind of example was rendered in exactly the same way, and everything is completely flicker free. We've got no issues with our Radiance Map or our light cache because we've generated everything from world and on multi-frame incremental. So the point of this is that a lot of people know how to render animations, but not a lot of people know that you actually can generate this in one pass rather than separately, because a lot of tutorials on the internet are teaching it as if you have to generate these elements separately. But if you do the multi-frame incremental and fly-through mode, Vray will automatically know that you only need to generate that fly-through mode once. Okay. So that's relatively simple. And then the next scene I'm going to show you is a kind of slightly different version of that, but it's a little trick that we have kind of learned, which really saves time when it comes to rendering animations. We get lots of scenes which are set up where only a few objects are kind of animating, and these scenes can be really annoying. I'll show you some examples. So if we have, again, we look at a chalk example. I mean, in this chalk, we have a few things that are moving. We have simple people and cars that are moving. So here we have some people moving. This is annoying because this scene is a classic example of we should be rendering this in fly-through mode. Yet we've got a few objects that are moving. If we have to go to a full pre-pass or brute force method for this, we're going to double our render time. So we don't want that. Again, these are really quick turnaround projects. We don't want to be able to render this and pre-calculate everything. We've got this very small section of our image which is actually moving. Everything else is a classic fly-through static method. So how do we combat this? It's surprisingly simple. Let's look at our scene here. We've got a simple scene, same camera movement again, but these balls are moving. Now we could render this in brute force and risk it and turn our settings right up. there's a kind of tendency when people use brute force. If I stick this on brute force now and light cache and have turn off my from file with my light cache and have it on single frame, and there's a tendency in brute force just to kind of up this setting to something stupid to get rid of the noise. However, brute force works a lot better when you just up the adaptive DMC. And people don't actually are kind of scared of turning this adaptive DMC up to a kind of what looks like a stupid number, but you'd be surprised how much better results you get, and render times aren't considerably more when you have your brute force subdivision settings a bit lower and your max subdivs within your DMC much higher, like 48, for example, which sounds crazy, but when you actually have a lower brute force, it can work really well. And you kind of, it works because brute force doesn't control all of the noise in your scene. You get noisy results when using brute force because of the way that brute force calculates the light within the scene, but it's not the source of the noise. Now, I want to talk about noise a little bit because it can be a nightmare in animations before we move on to kind of solving this scene. But noise can be real problem in animations. It's much less obvious in static images, but in animations it can be a real nightmare. And the main kind of cause of noise is both the DMC and obviously the noise setting here. So we can reduce the adaptive amount and really tone down our noise threshold. With animations, I like to take this to 0.001 and have my minimum samples on 16. I can leave my adaptive amount, but sometimes we take this down as well to 0.75 or 0.65. And then it's understanding what this time independent button does. It's quite an interesting setting to understand because you can produce more natural results depending on the speed that you have to render. Now, if you're rendering very high settings with low noise thresholds and a high DMC, then if you're rendering animations, then you kind of want this time-independent button off. What this does is this gives you more of a dancing noise, whereas the noise actually kind of like speckles around your scene like a real camera films, right? Now, if you have a not very high setting within your noise threshold or your DMC, that's going to look awful. It's going to look really obvious, and you're going to see that really a lot. This is especially evident when you have this unchecked, when you don't have enough samples on your glass. It really affects refraction a lot with dancing noise. I'll try and show you an example of this in one of our films that we didn't have enough time to render the, so look, we've got it here, to render everything properly. Let's find it within our, if we have it here. Okay, we'll try and find that in a second. We don't have it here. No, we've just got this one example of that one I just showed you there. But we did another project which I thought I had on me. I'll have a look for it later. Which basically we had a lot of kind of static noise issues, and we were really experimenting with the time independent setting. And there's this kind of like, you get two different problems with this. One is the static noise and one is the dancing noise. So I said, if you uncheck this, you get dancing noise. And again, you want to uncheck that when you have very high settings because it gives you a more natural noise effect. But if you don't have too high settings, you want to keep that checked. And you might see a little bit of that kind of static noise. Those of you who are experienced in animations will know exactly what I'm talking about. When you get that either dancing noise or static noise and you're not too sure where that setting is coming from, it's coming from this time dependent. So this, if you uncheck that, it's going to essentially create a new noise map for every frame. If you check that, it's going to kind of generate an average noise and keep that static for the whole of your animation. So understanding what this is and how to use it to the best of your advantage for your scene is important. Sometimes the static noise can be really obvious if you've got really large surfaces of one material, or chalk animation, for example. So within chalk animation, we can sometimes you sometimes get better results if you turn this off with higher settings, because then you don't see that kind of really obvious static noise on your geometry or on your rendering. But when you've got kind of more complex scenes with much more detail in the shadows, then you want to ideally leave this on, because the dancing noise would probably be more obvious in those areas. So again, it's a scene-by-scene basis, but just understanding that brute force is not necessarily the cause of noise, and that you have to kind of change your adaptive and noise amounts here, understanding the time independent setting, and then not being scared to up this adaptive DMC to seemingly too high values. Yeah, this scene was quite different because we wanted to render this with a Radiance Map, but we don't want to have to pre-calc everything. So the way we did this was quite interesting. You can basically generate the fly through exactly the same as we set up the last animation. So we have our what we've got here in this file. We have from file set, and it's loading our previous Irradiance map that we've created. Likewise with our fly through animation, it's all loading as if it was in fly through mode. But what's going to happen if we just render this now, or if we pre-calculate this like it is now, and then we render it like it is now, we're going to get very, very strange results. Because our objects are moving, our objects aren't static, so it can't generate a consistent Irradiance map across this when we're generating it in multi-frame incremental. It's going to get confused because it's adding maps, it's adding detail to a map which is changing. It's not remaining the same. And how the multi-frame incremental works, it just adds kind of detail and intensity to the kind of the areas it's already pre-calculated. So it's looking for the same areas in every single map, just but it relates it to where the camera is. So this is going to cause us problems. So what we want to do, we want to pre-calc this with our moving balls off, with our moving elements off. And you can either have that on a layer that we hide, or it can be a separate XREF, for example. So like in the example that I showed you with the moving people, the people and the cars were on a separate XREF that we can reference in and out of our scene. So our camera file is our master file still, with no actual geometry in. It's just got our lighting and our camera. And then we're referencing in our buildings, but then we kind of like turning off our reference of our moving object when we're pre-calcing. So it's not actually generating any information for the pre-calc for those balls when we generate that pass. So where's it going to get the information from? Is it going to render it without GI? No. What it does is this little setting here in the material. So we can select the material that our balls are on. We can go down to options, which is normally hidden in a little area down here that no one really goes into. And we can turn off use Irradiance map. That by default will be on, and we can turn that off. So again, what's that doing? It's essentially telling Vray, when it renders that material, to not think that it has an Irradiance map attached to it. So it'll automatically, by default, render that in brute force. So it will render those objects only that are moving in brute force. So there's advantages and disadvantages to that. The advantage is we can obviously pre-calc everything separate as if it was a fly-through mode, very, very fast. So it's going to render 95% of our image in kind of Radiance Map light cache, and then it's going to render the second 10% or the last 10% just in brute force. The disadvantage is that there's no real way of controlling the kind of brute force setting of those objects. I'm not 100% sure, to be quite frank, is if you go to brute force and then change the subdivision settings here, and then turn it back to Radiance Map, that it's actually, when it renders in brute force, it uses those kind of save settings or anything like that. I'm not entirely sure where it gets the brute force settings from, but it's always worked, and it means that you can kind of create those scenes very quickly. So basically, you pre-calc it without the balls, and we have that material selected. You then click Unhide, and then you, with everything saved on from file, you can then render your animation. So with our setting on from file, and with that, we've loaded our Radiance Map. We just do a quick test. Just make sure we're not going to freeze our computer when we do it. Turn on our frame buffer, make sure our don't render final image is not selected. There. So these are quite high settings, but we're rendering fixed, so it should render quite quickly. Not through Backburner. Make sure our light cache is on from file, not on fly through. So you can see that it's rendering the balls and the shadows, no problem. No kind of errors or kind of strange artifacts with the Irradiance map, because it's rendering those balls in brute force. It's rendering everything else using the pre-calc, but it's just rendering these elements that are moving, including the contact shadows of the object, which I don't fully understand how that works, but it works. You don't have to... I've seen a tutorial similar to this in person with Vray before, where they kind of introduced me to this technique, and they made the actual surface that those objects were on as well a material rendered that, with that option checked in the material, so that also renders in brute force. But our tests that we've done have been very successful without having to do that. So don't worry about your contact shadows or even your direct light shadows onto your surfaces which are generated in that light cache mode, because in our experience it works fine, and it means that you don't have to create complex scenes where all your contact surfaces of your objects that you want to render in moving objects have to be created in a similar way. In our experience, you don't have to do that. So that's really interesting. And then what we get is a scene like this, which works fine. We have our contact shadows moving. We have our balls and our scene with no flicker and no noise. Okay, sorry, we've got a question. Let's get a mic.
Paul, in this case, do you use multi-frame incremental for the Radiance map, right?
Sorry, can you repeat that?
In this case, do you use multi-frame incremental for the Radiance map?
Yes, so
Okay.
in this method, the whole point of this is that it's generated exactly the same in the fly-through method. So we're using light cache on fly-through, in this case on world, because it fits our scene. And then we're using multi-frame incremental on the Radiance map, and in exactly the same way that you would generate a fly-through animation. So you're imagining the balls aren't, the moving objects aren't there, and you're just generating, you're rendering the image as if there was no difference between a fly-through animation. You're just then you're checking that checkbox in the material, and you're making sure you're generating the Radiance map and light cache without those elements included. And then when it comes to rendering, you unhide that layer, or you reactivate the XREF, whichever method you're using, and then you can it will render absolutely fine. Yeah. Okay, we have another question.
Yeah, I was just wondering, for the animations, did you use any anti-aliasing filter, or do you have it off, or area?
Well, we can see that exactly in our model here. I always see people use this much more than we do, to be quite honest. When we render with this, I reckon 70% of the time we leave this off, basically.
For animations?
For everything.
Oh, okay.
Because it gives us a sharper image. basically, because we end up sharpening things anyway. It's like when they do post-production tutorials, they always add sharpening, and it's kind of things like we just, especially when it comes to trees and details and things like that, we want to control how that blurs in post. And for us, more than often than not, we leave it off, and it gives us a sharper image. If we put it on, we leave it on area. And the only reason why we would ever area is the fastest. And if we would ever change this, is if we were getting moire effects within very repetitive geometry or bitmaps with a kind of opacity and things like that. So if we're getting a kind of strange moire effect, if those of you who don't know what I'm talking about, I don't know how to spell moire. Does anyone know how to spell moire? Jeff? M-O-I. See if we can find a good image that illustrates it. But you can kind of see it. You can kind of see it where you have lots of repetitive lines together, and it's this kind of. You can see it on the shirt here quite evidently, where you've got this really strange result in the lines, and there's different. That's the only reason why we'd ever change this from anti-aliasing filter. So, for example, if these lines were much finer in this model here, and it was creating strange results, then we might change it to Capmel ROM or the Vray sync filter are the other two that we use basically. And the differences between all of these are kind of very, very subtle and something that I'm not really too experienced with, but I know from what I've been talking to with other people that these two particular options are really good for solving moire effects within the model. And that's the only reason why we would ever change from area, basically. But again, 90% of the time, we don't have that on at all. Because all that is just the way that the pixels blur together. And yeah, especially when you're rendering at a lower resolution, you kind of want all that detail to kind of remain, really. Okay, we have another question.
Yeah, just to clarify, the pre-calc you do regular fly-through, and then when you animate, you switch to the incremental.
Say that again, sorry.
I just wasn't clear on the actual pre-calc. Do you use the multi-frame incremental, or do you just keep it on fly-through?
Well,
with the method you just showed.
Multi-frame incremental is for the Radiance Map. Fly-through is for the light cache. So if we resort back, multi-frame incremental here is the Irradiance Map. And then fly-through is the light cache. So what the fly-through of the light cache is generating one pass for the whole animation for the light cache, and that's separate. And then the Radiance Map is creating several different files, which is adding detail to creating one file. So when you create that Irradiance Map, you're only creating one file, but it will calculate it over however many frames you set it to calculate. So this will be on. You could leave this on 10, and then if you leave this on 1, by default it's going to generate an Irradiance Map every single frame, and it's not going to save them out separately. It's going to generate it on frame 0, and then on frame 1, it's going to take more information from the new frame, and it's going to add that to the previous map, and vice versa. So it's going to create a kind of layered map, which has a lot of information in it, but it's only one file. Now, the reason why you don't have it on 1 is because there's very little difference between frame 1 and frame 0. So it's only going to add a minute amount of extra detail to that. You want to give it enough difference in the kind of nth number that you choose for here to make sense. And again, I am quite confident I could render 3 files in this particular instance, which will generate my map very quickly and give me the similar results. I would do that if I was in a rush, but for this case, we had it on every 20 because I think that gives us a detailed map, which isn't overdoing it, and it generates it fast anyway, so why not? And it's essentially generating 1, 2, 3, 4, 5, 6 maps and combining them into one map. So that's how it works.
And the reason you're leaving the reason you're using brute force on the moving objects, or you're leaving them out, that's just to speed up the pre-calc?
it just enables us on simple scenes where we've only got one or two moving objects or one or two materials attached to those objects that are animating. Otherwise, we'd have to go through what I'm going to show you next, which is rendering the kind of full-on pre-pass method, which takes a lot longer to calculate and a lot longer to render. So by separating the moving objects from the scene in a simple case like this, you don't have to pre-calculate every frame. You can use the fly-through method of pre-calculating, which is much, much faster and renders much, much faster, basically. So we're kind of cheating the system to not have to pre-calc everything, because there's no need in this file, because we've only got 10% of the pixels of that image are actually moving and the other stuff isn't. So it's much more beneficial to render that in a fly-through method, basically. So this little cheat in the material gives us that ability to render just those objects in brute force and everything else with our pre-calculated light cache. Because brute force on it, if we rendered this scene just from brute force, it would take twice as long. And if we pre-calc this in a kind of Radiance Map light cache method properly for a moving object scene, it would take even longer. So yeah, we're trying to save time. And to be honest, the fly-through method, the fly-through calculation method gives us the cleanest results anyway. It's much cleaner than the pre-pass method, and it's much cleaner than the brute force method. So we want to do that as much as possible in our scene. Again, it's a kind of judgment thing, because if you've got loads of moving objects, then it might be more hassle than it's worth finding the materials of everything and changing that switch. It really depends on the complexity of your scene and what is actually moving. It might be practical to go into the materials of a car. If it's a full rendered car with 15 materials, it might take 10 minutes to go through 15 materials and check that checkbox, but then you don't have to then pre-calculate everything. So it really depends on your scene, and it really depends on the time versus effort and quality and everything else. So we use it on simple scenes where simple things are animated. Hope that answers your question. Are there any other questions about this method? Cool. So hopefully that gives you a little bit of a trick to use when you're kind of rendering simple scenes like the one I showed you, when you have moving cars or moving people, but everything else is quite static. And that'll be quite a lot of the time, to be honest. That's why we think it's quite a good technique. I mean, very rarely in a scene, unless you're doing very complex animation, will you have lots of elements animated or things. Often it is just cars or people or trees, and it's very easy to then isolate those elements and render those in brute force, and then separate everything else so that it dramatically decrease your render time. Okay, we've got a few questions online. Let's just try and address some of those.
So will it will increase the rendering time if you generate more passes for the Irradiance map? That's the first one. Generally, if you have a higher setting for your Irradiance map, it will take longer to render. So if you have more passes, that Radiance map is by default a higher setting, because it's got more detail in it. So I'd say yes, but very, very minimal in this case. If you generated a Radiance map every 5 frames or every frame, you're going to have quite a big Radiance map file. The file size is going to be big with a lot of detail in it. So I think the final production of the render time would probably be a little bit more, but I don't think significantly more. I just think it's kind of pointless to render more Irradiance maps than you need, basically. Again, it depends on how dramatic your camera's moving, and what is kind of moving around. If you're moving around a corner and that transition is happening sooner than 20 frames, then you might want to render every 10 frames. But again, I mean, in some cases, we've rendered a Radiance map at the beginning and the end, and it's been fine. So it's got data there, and it's got data there, and that's all it's needed. But yeah, generally, I'd say it would increase render time marginally. Okay. Next question is, he faced a lot of noise and reflective surfaces when he's got glossiness set to 0.85, really long render times, and he wanted to know, what do you recommend to increase the setting without adding more time to the render?
For glass?
Glossy or noise and reflective surfaces with glossiness.
Yeah.
Yeah, we've had that too, to be honest, and I think there's a few ways you can. There's no real way of getting rid of it without even adding a little bit of time to your render time. You know, if we make a glass material, it's essentially with glass. I mean, you probably should know this, but you don't want really the reflective glossiness to be below 1 if you've got a glass. Some people put their glass on like 0.9 or 0.9, 0.98 with a subtle hint of kind of like specularity, but not 8.7, 9.7, with a subtle hint of specularity. But as soon as you stick this on 1, it's going to dramatically decrease your render time if you are changing this to 0.95 or 0.97, and the difference is marginal. And for me, it doesn't change the realism of it, basically. So I always leave my reflective glossiness on 1. This is, I mean, it's basically you're talking about the refraction subdivision. That's what's giving you that noise within the glass, basically. If it's the glass or reflective objects, it's both the subdivision in the reflection and the refraction. So you just want to increase those numbers. For kind of hero reflection or hero glass, we tend to stick this on 24 at the most. We won't really go higher than that because we want to control our noise really in the adaptive DMC. And again, increasing this will decrease noise. For reflective noise, the kind of noise threshold makes not as much difference. Reflective noise is mainly controlled within the DMC sampler, basically. So it's a combination. If you kind of increase this and increase this, you're kind of doing the same thing. It's just this does it globally and this does it per material. So what you don't want to do is have stupid numbers here and stupid numbers here. You want to have a kind of, if you need to up the setting of your reflective or refractive subdivision in your materials, then for certain materials, then do it. But just be careful not to kind of overdo both of these settings, because by default, this is going to increase your subdivision of your reflection anyway. So I don't think there is a way of doing it without increasing render time at least a little bit, but just be aware of your subdivision here, basically. I mean, we created some stupid materials recently where we had a shellac material of a glass-coated shiny surface, and we had a lot of problem with kind of render time and noise on that one, and we kind of solved it by kind of playing around a little bit with these numbers and just testing which setting was the kind of optimal time versus quality result, basically.
Okay. Next question is, when rendering moving objects that have multi-submaterials, should he go into each material and remove IR?
Yeah, so that will work for a car or anything slightly more complicated than our single metal material here. You would, if it was a moving full-on textured car, then you would have to go into that all the subdiv material and go to that option that we had a look at and uncheck use the Radiance Map. And again, that might, even if you had 50 materials within a sub-material, how long is that going to take? It's not going to take that long, relative to how long the render difference is.
So 2 quick ones here. Somebody wanted to show again where you uncheck the no GI option.
The no GI, the user Radiance Map. If you just make this a little bit bigger, it's just where I am exactly here. So we have our material. You just scroll down to options. You just open that up, and then it's user Radiance Map. And by default, that'll be checked, and then you just uncheck it. So it's as simple as that. And then by default, this material is now going to be rendered in brute force. But you want to calculate your light cache without your moving objects visible.
Okay. Last one here. He says in his light cache he uses 5,000 or more. How does he know how many samples he needs in the light cache?
For light cache, he uses 5,000. For what? Can you ask him what instance he uses 5,000, or just in general default 5,000 for everything? Basically, I'll start answering the question. I mean, you very rarely need to go above 2,500 or 3,000, and I'd only go near those numbers when on world scale. I wouldn't really go near that number on screen unless I'm doing some kind of crazy high-end still. certainly not for animation. Yeah, it's very rare that I've gone above 2,500 for anything in the light cache, to be honest.
His only clarification was for interiors.
Yeah, the interiors, it's good to have this on world. And again, 2,500 to 3,000 is a good number for a small scale interior where it's generating the light cache around that interior on world scale. But again, just watch out when you're on world scale that you don't have any objects very far away from your model, because it will, if you think about a subdivided box, it's kind of how this works is, if we essentially cover our box, our whole object in a box, and then we kind of add a few subdivisions, essentially that subdivision number is like this box. So at this model, our 2,500 is kind of covering about this much of the model. If you have another part of the model over here, now that 2,500 is kind of covering a much, much larger area, you know? So it's that kind of being aware of what's going on with your world subdivisions, making sure that you haven't got objects very far away, so that you can, all that detail in the map can be used there, exactly where you want it, basically. And that kind of explains it quite visually, and then on screen, it's exactly the opposite. You know, if we draw a little box here, a little plane, you know, if we imagine this, it's kind of the amount of data of the light cache which is kind of projected through our camera. So it's very much light cache of this level of detail, and then by increasing the subdivision. So if we say this is kind of like coming out of our camera, we make that size of our screen, and then when we're increasing our light cache on screen mode, we're essentially doing this. So the more detail we add, the more accurate our shadows and subdivisions are. So it's kind of this attitude versus this attitude is what screen and world does, and it's just understanding that properly and making sure you don't have stuff like that over there. Hopefully that answers some questions.
Paul, in this case, do you use an HDRI to light your scene, right?
Yeah, we use HDRIs, yeah.
Okay, but how you use it? Because you use a dome light?
Yep.
Okay, and how many subdivisions do you use for the dome light when you use an HDRI with the settings that you have in the DMC sampler?
Yep. We leave this on default unless we find an error, basically. I mean, here is on 20. I think the default is 8. You know, I think when you've got large flat surfaces of one material, like chalk animation you think is the easiest of all animations. But actually, to get a clean chalk, you actually have to render really high settings, because you've got these large flat surfaces which are very susceptible to noise, flicker, you know, to the kind of the shadow subdivisions not being high enough and things like that. So the sampling, all that's really going to do is increase the kind of, it's going to decrease noise in your shadows, and that can be effective on large flat surfaces, basically, yeah. So in cases like large flat single material surfaces, then you do want to up your shadow subdivisions to something a bit more sensible. 20 is quite high. But normally we only change that from 8 if we feel we're not getting the result we need. What we do a lot is render non-anti-aliased animations, like very early on, to just identify where the problem areas are, and like all your lines will be, you know, not anti-aliased, so they won't be very, very nice lines, but you'll get a really good sense of the light and the shadows and everything else. So we render out non-anti-alias animations very quickly so we can test it, and that'll render in an hour or less than an hour for even some complex animations. So you can go go for lunch, render a non-anti-alias test, and then you've got really great feedback of your of what's going on in your animation and the lighting really, really quickly. So you don't have to kind of render overnight or render farm to waste render farm time, and you can get that feedback much quicker by rendering non-anti-alias animation. Okay, so let's look at a different scene. Let's look at a full-on moving scene. Now we've got this one here where everything is moving, right? So we've got our kind of spheres are still moving. We've got all the surfaces moving. You know, we're in a kind of elaborate transformation scene within our architectural animation, and we've got kind of these blue guys are kind of shiny. We've got our spheres which are chrome. We've got our flat mono materials for our walls. You know, so we need. This is a kind of this qualifies for a kind of full-on pre-calc scene. So if we look at kind of like something we've done recently, which kind of qualifies as well for this kind of setup, is everything's moving. Everything's moving in this animation, so we need to pre-calc it, you know. This is kind of a test of something we're doing at the moment for the D&E. So everything's moving here. You know, there's no point trying to cheat this with materials and trying to make things in brute force. We don't want to render this in brute force. We've got, you know, we'll have lots of noise issues. So, you know, we've got reflectivity, moving objects. This was actually, the motion blur was even baked in on this one as well, because we weren't getting very good results with doing the motion blur in post-production because of the extent of everything moving. We've got kind of fine lines. We've got this initial inertia of the kind of pencil splitting, but then we also have that combined with fine lines of the Olympic cauldron here. So we've got lots of stuff going on, and this definitely qualifies for a kind of full-on pre-calc scene. If you look carefully, you can see static noise. So we upped the settings after this test. When we get to kind of this level and we're looking at some of the areas in the background, you can just about see it. I kind of look out for it probably more than most people. It's kind of one of my pet hates. I even see it in final production films and things, and I'm kind of like, amateurs. It's just not acceptable these days, I don't think, to see that kind of thing. So that kind of, that you can see why we do that, and this scene again qualifies for that. Let's have a look at our final effect for this animation, and then we'll go through how we made it. So moving objects complex. So you can see here, everything is noise and flicker free. Everything is dynamically moving about. We have one or two intersecting objects, but that's a separate problem. So anyway, we're happy with that result. We're happy with that test. So to render full-on pre-calculated animations, let's have a look at how we might do that. Let's stick everything by default back to single frame. Okay, so what we first need to do is understand that we are generating not one Radiance map, we're generating lots of Irradiance maps. Now, what we need to do is put the Irradiance map on pre-pass. And we need to put the light cache back on single frame and on screen. Some people check use camera path while in this mode, and essentially that's going to do is, like I said, the use camera path option is the same as using fly through, so why not use fly through? The difference is that fly through will basically needs to be on single frame. whereas the use camera path can be on for multi-frames, but you're still kind of generating a map which travels across that camera, adding detail for the entire timeline, every single frame. And you can do that, and if you're still having problems after trying this method, then I would advise checking that option. But when you're doing so, just lower your subdivs to 1,000 for each frame, because you are essentially creating lots of data when you do that for every frame. But I tend to put this on a higher setting on single frame when I'm doing this. And basically, essentially what you're doing is that you are rendering out a separate file every single frame of your animation when you have this on pre-pass. Again, you'll do this as a first pass, so you won't render this at the same time. So we'll turn our don't render final image on. But essentially, you're baking in a light cache file within a pre-calced Irradiance map file for every single frame. So there's a few things we need to kind of note when we do this. Obviously, we want any elements off. Nothing we have to change in settings. We need to turn on our don't render final image there. So we need to save out our pre-pass like we did before. Just wait till Max responds. Call this CG School. Again, making sure that it's linked. If you just press that, our autosave will probably be somewhere else, which it is. It's on our server. It's not really going to find our server from here. So we'll locate our map we've just generated. Again, that's a dummy file. But there's actually we made a mistake there. Because this is going to generate a map every single frame, we want to put it in its own folder. We don't want to put it with all the other pre-calcs. So let's just within here create a new folder. Call it Moving Objects Pre-Pass. And we'll kind of drag that into our Moving Objects Pre-Pass, and we'll just click it and press Save. So we replace it. And just to be sure, let's just check where that's saved to. And it's not by default going back to that folder, so let's just make sure it is. Sometimes I check this a few times just to be sure. Because this can take a long time and you don't want to make any mistakes. Single frame. Again, I tend to kind of put that in with the Moving Objects Pre-Pass file. And that's just so I know that that light cache was generated for the pre-pass and not used for our static animation, for example. We don't want to put it in the same place. You know, you want to kind of define what these elements are and where they're going. So again, autosave needs to be on, which by default won't be in the right location, so we have to make sure that it is. It won't just link to where you have your save file from. So pre-pass, CG School, save. So now we're kind of ready to start our pre-pass. They've simplified this slightly in the newer Vray, and they used to have a few other settings, but we don't really need to kind of concentrate on that now. So they simplified it so it works better. And we're basically ready to pre-pass this now, but we want to do this for the entire frame range. But there's one really important thing to remember, is that if you notice this Interp Frames that will be available when we then pre-pass animation render this. So this is currently on animation pre-pass, right? So this checkbox is not available. If we put that to animation rendering, this checkbox is available. And we'll do that, we'll talk about that once we generated our pre-pass. But the first thing to really pay attention to here is that we want to if we currently have been using active time segment, that's not quite going to work for us here. We need to select a range and we need to go to -2 and 102. Because we're generating a pre-pass file, we need to blend these pre-pass files together. And because we're essentially creating a pre-pass file every single frame. And that's not really giving us enough, that's giving us a huge amount of data, but then we need to tell Vray to kind of use that data in a smart way. So we're using that data to essentially blend those pre-passes together to stop us from getting kind of flicker and extra noise and things like that. So it's kind of merging the kind of frames together. So if we're rendering frame 5, it's going to kind of merge the light cache files of frames 3, 4, 5, and 6 and 7. So although that's on 2, that means 2 before and 2 after. So it's blending 7 Irradiance Map files together, right? So if we change that to 3 when we come to rendering, that's going to blend, 7 files together, and so on and so forth. So what happens when we render on frame 0? If we haven't set that to -2, it's not going to have those frames to blend properly. So it's not going to render frame 1 or 2 correctly, right? So we have to generate our light cache file 2 frames before and 2 frames after, or if that's on 3, 3 frames before, 3 frames after, and so on and so forth. So once we've generated that light cache map, we'll render that out, and this is different to the previous method because we can send this to the farm to all of our nodes. So it's not dependent on adding detail to a single map. Each of these maps are independent from each other, so they can be made on the they can be generated on the entire farm that we've got to speed the process up. So if we have a look at these files, for example, we have our pre-pass file already calculated. We have our light cache. We have our pre-pass dummy file that is generated when we press save on those maps. And then we have the rendering of all of the files here. So you see it displays it in a funny way, but Vray reads it correctly. So this is like 00, 001, and then it's got -001, 002, -002. It doesn't matter what order that's displayed in, that's just a naming thing for Windows, but Vray will read this properly. It will read it as -2, -1, 0, 1, 2, 3, 4, 5, etc. So we generated this from -1 to 102. So it's individual maps for every frame. And then once we've generated that, we can put it on animation rendering. And we can browse to our complex pre-pass file. And we can select the first dummy file or the first frame. It doesn't really matter because these are linked. And the other important thing we need to remember here is that now we've generated this, we don't need to load our light cache from file because the light cache data for every single frame was baked into our pre-pass. So we can actually go into our GI engine up here and turn this to none. So we've only got our Radiance Map selected. And we're loading that from animation rendering, and we're making sure that it is on the right, it's loading from the right folder. Now we can change this setting here if we need to. Again, if we want to, basically, the higher this number, the smoother result you'll get. The default is 2, which blends 5 frames together, and there's not much difference unless you're finding problems. What I do is put it on 2, render 10 frames in the middle of your animation, and just see if that's working fine. If it is, leave it on 2. The benefit of this is you've already created your Radiance Map, so you don't have to wait for light cache or Radiance Map to load. You can just put this on whatever you think it should be, and then do some render tests, loading from file all those files. 2 normally works fine. I've very rarely had to kind of adjust this or make it bigger. But again, if you've got a scene which has got some tricky lighting conditions and the light is you need to merge more of these passes together, then you can just do it here. But just be aware that if you change this number, you've only generated it from -2. So if you change this to 3, you have to render from frame 1 to 101, to 99, sorry. Because you have to load 7 Irradiance maps here. So you just have to make sure that you're aware of what the consequences are of that. Okay, so we need some explanation of that from the crowd here. So basically, what we're doing here is this is the Interp Frames. It's interpolation of the Radiance Map frames that we've generated. We can see all of these files here, and you can see here that we've got a -2 here. I mean, ignore the fact that we're starting from frame 00 here. That's just a Windows naming thing. We've created 104 Irradiance maps from a 100 frame animation, right? And that's because when we come to render from frame 0, yeah, to 100. Yeah, I'll just finish my clarification now. I've started. We need to basically blend those 2 initial frames and the 2 frames after that frame together with our current frame. So we need to, if we started on frame 0, we're blending the pre-calculated frames of frames -2, -1, 0, 1, and 2. So we're blending all 5 frames together from our pre-pass to create the render frame of frame 0. So again, if you had this on 3, like I was explaining, you would have to put this on 1 to have that data, because we didn't render from -3. We only rendered from -2. Yeah? Hopefully that makes sense. We can put this back on 2. So we've got another question. Sorry, Jeff, can we pass us the mic?
So I guess if you knew in advance you're going to blend 3, you would do -3 to 103?
You can play it safe, and you can when you're generating the pre-calc, you can just say, okay, I'm just going to do it -5, just to give me some leeway later on to do it. From experience, I know that I think maybe once had to up that in the million times that I've done this, so I know that -2 will probably be fine, you know. But the benefit of this is because when you're generating the Irradiance map, it's not really dependent on generating it from the whole camera path or the whole scene like the light cache from the previous method is. If you did find that you weren't getting the right results and you have only generated from -2, say, you can just go back to rendering pre-pass and then render from, say, -10 to -2, and then you've generated a lot small pre-pass, you know, and then you might do another set of pre-passes from frame 102 to 106 or whatever frame range you need. So you can go back and make more pre-passes if you need to without having to pre-pass the whole scene again. If you're finding that you then need to go back and generate more blending frames.
Okay, so do you only blend more frames if you're noticing, I guess, artifacting or some kind of problems?
Yeah, if you're noticing that you're getting still a slight amount of flicker in your Irradiance map, because your Irradiance map's the biggest, obviously, as we all know, the biggest problem when it comes to flicker. So you might need to blend more. Again, in my experience, I've never had, I think only once had a problem with still getting flicker after blending more than 5 frames. As soon as you up this, your render time will dramatically increase, basically, because it's taking these pre-pass files are quite large, and you're blending more, like 4 more frames. As soon as you up that by 1 number, you're blending 4 more frames, because it takes you're blending 2 more frames, 1 before and 1 after. So if you up that to 4, you're rendering 4 more frames. You know, you're blending these together, and it kind of has to. It's quite a complex procedure that it does, because it not only has to read these frames, but it kind of has to like as it kind of illustrates here, it has to interpolate those frames. It has to kind of read them and blend them together, and that when it does that on rendering, and it can take a lot longer to up that blending setting, basically. Were there any other questions about this? Jeff? Cool. So we can see here. Let's put this back. Okay, so we're on rendering. We've turned off our GI engine, our secondary GI engine. I can turn back. We can uncheck don't render final image. If we've got any elements, we can turn those back on. Haven't really changed anything on our settings. We've kind of happy with our starting from frame 0 and ending on frame 100. Just go to single frame for now to kind of illustrate. Just make sure that this file is on Affinity. I think it's the other one. So if we go to a random frame here, just for speed, let's just make this off. So we've got this loaded within our animation. And we can, within our kind of desktop, we can just do a few tests to make sure that we're not getting any artifacts in our Radiance map. So it will skip the generating light cache and a Radiance map, and it will just go straight to rendering. And you can see now we have very smooth results. So we've got no real artifacting in our shadows, and everything is kind of working properly because it's reading from that nice Irradiance map pre-pass file that we've generated. And again, this was the same method that was used for that example I just showed you. So this was all pre-passed properly. And all we've done after this for the final render that we're working on at the moment is up the settings a little bit for the noise. So there's like 3 different methods that we always use. We do sometimes use brute force, but it's very rare, and it's only if we don't have time to kind of set up files and we're being lazy. We know the rendering is not going to take too long, but I think it's more of a laziness thing if we send a brute force render animation. If we kind of just think the farm's free, we've got a little bit of time, let's just create some crazy brute force settings and send it to render. I can't be bothered to set up a pre-pass. And we shouldn't really have that attitude. We should always set up a pre-pass because in this method that I've just shown you, we'll render faster with better results than brute force. It's as simple as that. So there's no real reason to send brute force unless you don't really care about the results and you're in a hurry, you want to go home and you don't want to have a pre-pass. But if you're doing final production, you should always use pre-pass method because it renders faster and it produces better results, which is kind of the ideal situation, right? So I'm going to open one of the street scene from Jonah, have a little poke around rendering the kind of fish bar that was in that scene at the beginning, which we'll talk about later in compositing. But before we move on from these 3 kind of scene setup files, were there any more questions in the class or online for any of this? Okay, we have a few questions. I think we're going to start online.
First question online is, how do you make buckets in rendering follow your mouse movement?
When we're rendering, there's a little Vray checkbox up here, and it's called track mouse while rendering. If we leave that off, then it's going to do the normal thing that it does. If we check it, then we can zoom into our model and render just the buckets where we want to see. It's just a checkbox in the Vray frame buffer. Simples.
Next one here is, so they've had some really high render times when rendering things like frosted glass with simple animations. Any recommendations on how to manage that cleanly and quickly?
No. Frosted glass is the kind of like the holy grail of render time. Frosted glass is going to, if we do a little quick, if we've got the other file open, we've got that glass material we made. As soon as we start to mess around with the glossiness of our refraction and we create a kind of frosted glass, I mean, it's just going to take ages even to preview at this scale, let alone render those things. You have to really up the refraction subdivisions when you do this, and there's no way of getting that render time down when you do that kind of thing. I'd try and suggest, if you are really struggling and you don't have the time to do like a proper frosted glass technique. So this has even crashed my machine. This is how much Max hates frosted glass. But I try and find more creative ways of creating that kind of frosted glass effect, and it depends how close you need to get. Because you can see this is kind of noisy already, and we're on 16 subdivs here. As soon as you go to anything which is going to smooth this out, like 32, our rendering time is going to be huge. I think there's other ways of kind of playing with the refraction color to kind of allude to frosted glass, or allude to kind of some sense of slight opaqueness to it. So you're not kind of leaving the refraction on white, you're making it kind of slightly more gray, or so that you're kind of making it look more opaque without actually changing the glossiness. Because it's this setting here that's going to increase your render time. So I try and find ways of cheating the frosted glass effect if you don't have time to wait for it to render.
So I wanted to ask about, in your light cache settings, you're not using the use glossies option at all. A lot of times I'll use it for stills to expediting render times, but with animations, are you purposely leaving that off? Not using it just for noise reasons, or?
Yeah, for animation, we've experienced when we have the use glossy rays pass selected in the light cache, we've had more of the kind of like speckled white effect in our renderings and things like that, and the kind of pixelated white noise, which you can get rid of in other ways using the some of the settings in the color mapping and so on. But yeah, we tend to, we don't always have that on even for stills. Sometimes we have it on, but we always have it off for animations. Basically, it's just, I guess it's a force of habit, and we haven't really gone back to check if it's improved since we started to not use it, basically. So maybe we should do a test with it on for animation and see if the problem's still there. But for us, we experienced noise artifacts when having that on for animation. Okay, are there any more questions online, Jeff? Or? Okay, so let's go. Oops. Let's open one of the scenes for Jonah and have a poke around. Let's close some files down. Okay, so if we go to our street scene and we look back at our TRA30 shot, which is our kind of like transformation of our street in real time. So we're going to be kind of looking at this simple scene here. Well, it's not actually simple. I don't know why I said that. It's this complicated kind of model here that we've kind of comped into the footage. We discussed a lot of the animation techniques on day 2, but we're going to look at the kind of render setup for this and the kind of way that we kind of comped it later on. So it's just this bottom element for the fish bar that we're going to look at. We can look at kind of like the lighting setup in this file. So just wait for Max to unload. It's quite a heavy scene. What we did was we proxied our Vray, our ray fire mesh, so it's kind of slightly more manageable, and we have that in a separate file. So if we go to our XRefs, there's actually nothing in this scene apart from our light and our camera, which is always good practice. And then we have our, if we just turn off a few things one by one. So we have our kind of base geometry with our camera projection of our footage, giving us our kind of quick texture, our kind of light bounce. We have our fish bar, the animation of our fish bar. And then we have the kind of fractured wall separate to that. This object here that you see, which is kind of already built, is actually a kind of animated plane material effect. So it looks like it's kind of built there, but it's actually not. It's actually kind of the material is animating from bottom to top with our wall as it builds. So this geometry here doesn't really render in. So let's just have a little look around this scene. So again, we've got our fish bar here. There was actually nothing, this was a kind of closed surface in the footage, so we've actually added this room in. And this is simple texture, simple animation, simple lighting setup. We haven't textured our back. We've just got the kind of sides because we don't really see anything more than the side view on this one. Scrubbing through the timeline is a struggle for the kind of main proxy file. So let's go into the actual model file for the mesh here and we can see what's going on. But the lighting here is relatively simple. It's just lit with a Hdri again. It's lit with that Hdri that we briefly showed you, which was, if we find it, let's just have a look in the file so we can see where it's located. Okay, so if we just look at this, locate our Hdri. Oops. You can see we have our Hdri here. So this was taken as, let's just try and actually get in that folder. Hdris. Look at the JPEGs that we're going to use to. I'm not going to go through how we made the Hdri, but I'm going to kind of introduce you to a few bits of kit that we used to capture them, and just understanding what's the best tools really. So let's just quickly find our files here. So like we kind of briefly explained, this is our Hdri, and it's made up of 7 different exposures at 45-degree angles, taken on a kind of fixed tripod, which you can kind of see just here. What you can also kind of see here is our Nodal Ninja, which is our kind of device that we're using to rotate our camera on a fixed angle brackets. So we're rotating that every 45 degrees and we're taking 7 different exposures. And we're not doing that manually, we're doing that using a promote control. Is a kind of like device which connects our camera, to our camera, and we can kind of really easily do time lapses and exposure bracket, multi-exposure photos and things like that. And then we're doing all of that with a 5D with a non-crop sensor. Again, if you did this on a cheaper camera or even a 7D, you wouldn't get a completely spherical image, you'd get a cropped image basically, which is important when rebuilding the kind of 360 degree thing. But you can see from our Hdri that we're getting a great amount of lighting data. So you can bring it right back and we can see that the sky is our light source. And it's giving us the kind of detail that we need for our lighting. And because we're kind of always within the streets, we're not going above it, we can just use this Hdri. We don't need to use any other light whatsoever. You can see in the file that there was a directional light, and we did play with that for a little while, trying to recreate the lighting as accurately as possible. But we found that once we actually played around with the Vray light, with the kind of settings of that Hdri, we could get it roughly working. What we sometimes do is kind of activate Vray RT with nothing in the model, and just get our dome light source in the right place. And I actually did a kind of test for NVIDIA's new Maximus system last year, and testing specifically RT in production. And Found it actually very useful for lighting setups and material setups for scenes. And I wrote a big case study on the NVIDIA website, which you can kind of hear more details on that if you're interested in kind of learning a bit more about RT and its relevance within ArcViz production. So you can see here, let's have a look at our dome. Dome's on 1. If we go to our settings here, is that for our light? Let's just have a quick check. So yeah, we haven't really done much. We've kind of altered our render multiplier. We've actually left our inverse gamma on 1. We're kind of happy with our exposure. What else have we done? Let's have a look at the settings here. It's on. We've kind of, here's where we've kind of altered our rotation. So we've kind of done test renders and we've seen that that is where our kind of lighting is working best. And we haven't really done much else. It's a relatively simple setup. So it's just about getting the light in the right place. And I guess you don't really have to do, because we were kind of using Nuke and we knew that we were going to kind of color correct things anyway, and as long as you get the light source in the right place and the colors roughly right, you don't have to spend ages getting it kind of matching the, the geometry and everything perfectly. So if we just go to our V-Ray cam here, let's look at our render settings. So at the moment it's on single frame, so we can illustrate and test this file, but this was actually pre-calced in the same way we did the moving objects test a second ago. So it was pre-calced to animation pre-pass and then rendered blending 2 frames together. We did render this in brute force initially, but we found that even with very high brute force settings and DMC settings, because this was kind of recessed within a kind of narrow alley, there was very little actual direct light that could add photons into here. So we were naturally getting a lot of noise within this space. It's a good example of a scene that had a lot of noise. We played around with, I've never been truly convinced by the V-Ray light portal. As an ex-Mental Ray user, just knowing how good the Mental Ray light portal is, and the V-Ray one just is nowhere near as good, basically. For those of you who don't know, the V-Ray light portal is supposed to take kind of color data, and it's good for certain situations, like interiors, when you've got direct, when you're using a Hdri for interiors and you want to boost your kind of shadow crispness within your interiors, then the light portals on the windows are good, and then they're not fill lights. They're just a V-Ray plane that you'll select, attach to your windows, and then you'll select the skylight portal option here. And we tried that with getting kind of more light down, or not more light, more kind of detail in our kind of pre-pass calculation into the space, but we found it with limited result. And when we pre-calculated properly at better settings, we found that we can get rid of the noise. But if you're doing interior scenes, the skylight portal option within the V-Ray plane is good to have on all of your windows, because it will give you sharper shadows within your interior. And that's not sharper shadows if you've got a kind of direct light streaming in, that's just sharper shadows in general, and contact shadows and everything. You'll get much cleaner results. But again, the way that I've used the Mental Ray skylight portals in the past, it's just not got the same functionality for increasing photon emission into scenes, which is kind of what I wanted in this case. But be aware of its uses if you are using these. So let's have a look at what we get when we render this. We actually also, because we've got, if we look back at the clip, or the moire effect even, if we look back at the clip, we can see that there's a lot of movement, there's a lot of animation in this, and similar with the last kind of thing I showed you as an example, what we did for the D&AD Awards, we needed to render in motion blur, which sucked, because that kind of triples your render time. But we have these kind of, we have these chairs that are kind of spinning in very fast, and we have lots of kind of detailed movement in the bottles and things that are kind of coming in. So we kind of, for that element, we didn't really have to do it for some of the other elements, but for this element we did render in motion blur. And I'll be talking about that in a second, because it's just a checkbox and we can alter the settings very quickly. It's just here, but we'll have a look at that in a minute. So we rendered this with a color mapping of linear multiply. Again, we always take down our brightness value a little bit. Obviously, we're working in linear color space, and there's nothing else too special. I'll be talking about the kind of render passes in a second, and which ones you need for rebuilding your RGB. In Nuke, that is. And yeah, let's do a quick test at kind of mid-range HD, just to kind of see what this is doing. Before we do this, let's just make sure we're on a low thread priority for the recording, which we are. Taking that down, which is good. Maybe not quite as far down. We want to render it today. So also a good practice actually when you're doing stills especially, but also works when you're working in full HD. If you are you're wanting to test render your scene, it's really good practice to render your entire scene fixed, so you can see your entire image, and then actually activate your render region window and then start to render elements in detail if you're testing materials, because it will give you a great idea of your entire scene first, and then you can actually go in and start to test certain elements and how they're working. So here I'm kind of testing the lighting. Clearly, you know, all my radiance map isn't high enough. My you know, the noise values give me, I can't really test the materials, but I can get a sense for the lighting very, very quickly. And you can see here, if I switch to my alpha mode, you can see the alpha of my kind of scene is affecting my base geometry that I have in a separate file, and that's with the multi-matte shadow material that I was talking about before. So we can have a look at that scene again and recap on that. When I open it in a second, let's just open up a new Max and just get that loading while I continue. So this is the base geometry file that we can open, not the actual model file of our animated sign. So let's just recap here. So like I was trying to say, render your entire scene fixed and then go in and on activating your DMC again, and you can actually start testing what things are doing. Especially if you're kind of using motion blur, you want to go in and actually test a few frames first. This file has a habit of, because it's such a large file, has a habit of not liking to be moved in the timeline unless you're just rendering. But we'll try and move to a frame without the file crashing. I like to make things difficult for myself in live presentations by doing really complicated scene setups. The reason why this is taking time is because this is a very large V-Ray, animated V-Ray proxy. And we find that we actually use XMesher more these days. XMesher is a really great kind of meshing system for animated objects. I think for static objects we still use proxies mainly, but for animated objects we use XMesh more, and because it gives us a much better preview in our viewport of our geometry than proxies do, and they tend to be a lot more reliable. Okay, so if we change this to say frame 100 instead. But while that's kind of loading, let's go back into our base geometry file and talk again about this material that we have on all of our base geometry, which is our V-Ray material wrapper. And again, this is the same thing. We have our V-Ray material within the base of that material wrapper. We have our camera map per pixel with our texture linked to our camera, and that's projecting our footage onto our geometry from the camera. And we can mask this. We can do all sorts of different options we have within the camera map per pixel that we don't get elsewhere. And in our material wrapper, this allows us to create our alpha contribution for this, anything that this material touches as -1. So that our geometry that's within our space here, if we go back into our camera here, the geometry that we're putting within here will render, because that by default, obviously all geometry you put in has an alpha contribution of 1. But then we're telling this geometry with this material on to have an alpha contribution of -1. But we're affecting the shadows. So what that's going to do is it's going to give us the object that we're rendering that we're rendering normally. The kind of contact shadows of that are going to bleed onto our base geometry here. Now, there's two slightly different workflows that we used while doing Jonah regarding the use of the use of direct shadows onto the base geometry, which I'll talk about more when we start comping things. And it kind of is more about how this affects the alpha work. So we're telling the geometry to receive shadows from our other objects, but then we're also saying, is that going to be affected in the alpha? So by checking it, we're saying that the geometry in here is going to be kind of like completely clean cut, and by unchecking it, we're saying that the alpha of that contact shadows and of our geometry that we're rendering in is going to kind of bleed on through the alpha. It kind of makes more sense when you talk about this in composite, when you can actually see an example. But you'll get used to what this is in a second. So that's our kind of base scene. There's nothing too complicated with it. And our other scene is crashed. So we'll try and open that again in here. So what I'm going to do is just turn off one of the heavy XREFs, move to the frame I want, and then turn him back on. Pow. Okay. So we're kind of in the middle of our animation here, so let's do another quick render test at low res, with low settings. We're using a very low Radiance Map, and we're using a light cache of only 300 here, so we're going to get really patchy results, but we don't really care at this stage. I guess the one thing we did do with this file, which I found, was that we kind of baked in the ambient occlusion, and there's two reasons for that. Which is one, because the kind of Vray dirt pass that we were rendering out manually, which we still have in here somewhere. Or did we take it out at this point? Yeah, so we took it out at this point because I find this renders faster. You have less control, obviously, but it renders faster if you know a rough setting that you want. Shouldn't be on 20 meters though, mind. I don't know where that happened, because that's going to coat our model. But the dirt that we generated from this file got really confused with a few of the materials that we were kind of creating here, specifically this object here, which you can see this material, this kind of black and white material, is actually blending between, is actually trying to transparent map from a kind of plastered wall effect that we kind of have animating up our model. And we're doing that with a kind of animated gradient map with a bit of noise. And our dirt map just didn't like that and was rendering this top section black all the time. So we baked it in, and it rendered faster anyway than rendering it as a separate Vray dirt pass. If you're struggling with render time for animations specifically, just kill the Vray dirt pass. It's overly used anyway by a lot of people, and often if you kind of like get your settings right, then you don't often need it. But the Vray dirt pass will at least add 60% of time to your render time. it's the one pass that really does kill your render times compared to all of the other passes. So if you're if you're in a rush and you don't necessarily want it, then just kill that pass. Yeah, I mean, a lot of people are starting to not use it at all, actually, specifically in still images as well. Sometimes it's good for kind of, if you're using it in animations to refine a little bit of detail, which you might lose when you're kind of animating, but often even in our still image workflow, we're not using it too much. Again, if we've got time, we will add it and we will render it out. But if we don't have time, then we won't. For example, that don't think we actually used it in this scene, but even in that that last test I showed you with the pencil, there's no V-Ray dirt in that either. So let's do a quick test. Let's just make sure our low third priority is on. So in this scene, there were kind of 10 models, very similar to this, with the same base geometry and the same camera that were kind of used and rendered out separately. And we'll look at the comping of this specific element later on, and we'll also look at how to build a kind of complex tree with lots of different elements into one scene. So even on 300, it's taking a little while to generate our pre-pass. What you'll notice here is actually generating 5 pre-passes, and it can be confusing as to what all that is. The reason for that is because we've not got enough light down here. We haven't got enough light, and the reason why this is so patchy is because of our low Radiance map. So because there's not enough light, Vray is kind of overcompensating and adding, what it does if it can't find enough kind of photons from lights is it kind of overcompensates by kind of pasting from the camera's perspective photons. So it kind of like projects photons roughly from the camera's perspective into the scene to try and artificially simulate more photons in that area. And what that can do is give you a significant amount more noise if you have that extra pre-pass to your scenes. So that's why when we actually finally rendered the scene, because even as a test, you'd expect better results than this. Because you can see just how patchy that Irradiance map is. So we had to do crazy settings in we had to put this on, I think medium animation or high. We don't normally go that high. And we had to put our light cache on 3000 and generate a very expensive pre-pass for this scene, basically, to get that kind of quality back into our Radiance map. So again, there's no real defaults to any of this. Every scene is completely different. This was a very difficult scene to light because it's kind of within a narrow kind of space where the light is really finding it hard to get into, basically. I think what we'll do is we'll use our previous file that we were in, which is the kind of test file that we were animating our 3 different setups earlier on. And we'll render out a full HD still of that, and we'll talk about which passes we need for compositing, and we'll use that as an example to get going in our Nuke comp. But what we'll do, we'll take a 10-minute break while we set that up, and we'll refresh, have a drink, go to the bathroom, and we'll be back in 10 minutes to start introducing you to the Foundry's Nuke software.